Hi you guys, I'm going to make a video of how to solve triangles using the law of sines. Law of sines. In a non-right triangle with two sides and the included angle, the remaining sides and angles may be found by the law of sines. And as we talked about in class, A over sine of A equals B over sine of B, which equals C over sine of C. The law of sines always works for two angles and one side. And the law of sines may work for two sides and one non-included angle. Even though in the last screen I showed you that sine or A over sine of A equals B over sine of B and equals C over sine of C, they're reciprocals of the entire formula is also all equal to each other. So I'm just going to write there all their reciprocals. So that means that sine of A over A equals sine of B over B, which equals sine of C over C. When I'm looking for a missing side, I will use these because it makes solving for side A, B, or C easier. When I'm looking to solve for an angle, I'm going to put my angle on top. The best way to try to learn these is to do an example. So example number 1. Angle B is 105 degrees, side B is 23, and side A is 14. Well, the directive is for us to solve the entire triangle. The very first thing that I'm going to do is draw a triangle. I know because this is about law of sines, this is not a right triangle. And since it's not a right triangle, I cannot use the Pythagorean theorem. My next step is to go ahead and label my sides. I'm just going to make this triangle A, B, C. That means that this is side A, side B, and side C. I'm also going to plug in what I know. I know that angle B is 105 degrees. I also know that side B is 23. Just like I know that side A is 14. So since I have a pair, I'm definitely going to use sine of 105 degrees and that its side is 23. I am noticing though that this side is missing, or this angle is missing, even though I'm given the side. So I'm going to start with those first. Using the law of sines, and I realize that I'm looking for an angle, I'm going to write this as sine of A over side A must equal sine of B over side B. So I'm going to plug in what I do know. Well, sine of A is still an unknown, but I do know that side A is 14. I also know that angle B is 105 degrees, and I know that side B is 23. In order to get this sine of A by itself, I would multiply both sides by the denominator that I'm trying to get rid of, which is 14. So I'll multiply on this side by 14 and multiply by this side on 14, or by 14. That way, these two cancel out. So making this just a little neater, I want to get A by itself. It's nice to know what sine of A is, but what I really want is what angle A is. So I'm going to have to get rid of this function sine. And the only way to do that is to take its inverse. So I am going to do, or take the inverse of sine, or complete arc sine on the left-hand side. And whatever I do to one side, I need to also do it to the other side. The reason for doing this is that the inverse will cancel out the original function and leave me with just a. If I plug this beauty right here into my calculator, I get that angle A is simply 39 degrees. So it's no longer an unknown. I know that angle A is 39 degrees. Well, how do we find out what C is? Because of the triangle sum theorem, I know that all of the angles inside the triangle should equal 180. So I take 180 and subtract 39 and subtract 105 in my calculator or on a scratch piece of paper, and I find that angle C is simply 36 degrees. Awesome sauce. So now we only have one more side and one more thing to find in this triangle to solve the whole thing, and that's X. It's not X, it's C. So we need to find C, and C is a side. And since it's a side that I'm looking for, I'm going to put that C on the top. I know that C of sine of C will equal, well, any of these. Let's just use A. It equals A over sine of A. So what I'm going to do now is plug in what I know. I don't know what C is, but I do know that angle C is 36 degrees. I also know that side A is 14 and angle A is 39 degrees. In order to get this C by itself, I will simply multiply both sides by the denominator I'm trying to get rid of, which is sine of 36 degrees. Again, by doing that, it cancels both of those out and leaves me with the C that I want. And all I have to do is plug this bad boy into my calculator. If you plug that into your calculator, you will get that C equals 15. So now this is no longer an unknown. The answer is simply 15. And that's how you use law of sines.